Today we're going to connect the ideas that we've been doing already to some other algebra that we've done in the past. So last semester we found areas of rectangles. We have on our formula sheet, which you get for your test, an area formula for a rectangle that says length times width. I did not. So we already know our formula for a rectangle is area equals length times width, and we can use that even if it's algebra. So now length times width, my length here is 4x, my width is 3x plus 6, and I need to put that 3x plus 6 in brackets. And in algebra, we don't write the times sign, we just sort of like put a dot or put things close together. So now the question is, how do we multiply 4x times 3x plus 6? And this is where that first topic that we talked about in preparation is our focus in previous classes affects the next class. How do we multiply when we have a number outside of the brackets? So this is where while you're in class, you're like, do I remember?
You do 4x times 3x, and then you do 4x times plus 6.
Perfect. So having that connection earlier reminded us, oh yeah, this is where and it's called the distributive property. So as far as paying attention to words, it's interesting. If you can remember what it's called in the proper words, so we know I'm saying this is called the distributive property. If you remember the wording, it gets you to another level of being able to remember how to do it. Yes? Oh, wait. So what happens, what we did in the class, and you might want to go back and watch the video because you might not have been, I think you were there for that class when we talked about a bag of apples and oranges and you bought 3 of those bags. So the number in front gets multiplied by this. Each thing gets multiplied. So we would take 4x times 3x. How do we multiply? 4 times 3 is 12. X times x would be x squared. And then this one, 4 times a positive 6 would be plus 24. And we just have the variable x. So there would be the answer for the area of the rectangle in algebra. And I think I have it written. No, I don't have it. We can rewrite it here. I think there's a space in your notes for it. Okay, I'd like you to add the arrows here to your notes as well. Okay. If you have a highlighter, there's the important definition, distribution. This idea of the green arrows, that A going to the B and to the C, is called distribution. Have you heard that word outside of math class? Have you ever heard of like distribution when they're talking about bringing materials from one store to another store? Have you? So a distribution center, they sometimes have distribution centers where they take stuff, all the stuff is there, but then they bring that to the different stores in the city. So they have one place where it has everything, and then they distribute it, meaning that it's going to different places. Just like these arrows are going to the B and to the C, that's where the English language fits with the other language that we have. Yes?
How do you times letters?
So when we're multiplying the variables, okay, x times x, we just use our skills with exponents from last semester and say, how do we write repeated multiplication? I could write that with an exponent. You have x. So if you had x times x times x, you would write x cubed. If the letters or the variables are different, so if I have this, I have x's twice, but just one y.
So if there's 4 x's, it's x forward.
That's right.
You guys are
So we use distribution, this is a review, whenever we have an algebraic expression in front of brackets. Okay? This is a monomial, which means it has one term. Outside of brackets, you would distribute to each term inside. Hey, inside the bracket, we have a polynomial with 3 terms. Do you remember what that's called? Trinomial. Okay? Like, trinomial wasn't in your vocabulary 2 months ago. It wasn't a word you'd ever heard of. So again, the only way you know that word now is by our level of focus in class, paying attention in class, practicing what we, it's not like, oh no, me and my friends, we're always talking about trinomials in the hallway. That's what we do. Hey, did you see this trinomial on my phone? Right? That's a, no. Yeah, perfect. So it's only how we pay attention in class that helps us with that.
Are we going to be using a lot of stuff from last semester?
Yes and no. In that I'm not going to have on your exam a section on exponents, but we have exponents built into this unit. So the math always builds on itself. It's like, do we have to know grade 4 math?
Yes.
Yes, because you need to know your times table. But it's not like there's a section on your test that's like, grade 4 times table practice. No. So now, if we multiply this out, we have 4x times x squared. We multiply the numbers, and how many x's would there be? X cubed. 4 times a negative 5 would be negative 20. X times x, x squared. And 4 times negative 3 minus 12x. Now, the question I have for you right now, as far as we talked earlier about focus, when a question appears, did you try to do it on your own first, or did you wait for me to write it down and then you copy it down? Because if you were waiting for me and just copying down the answer after I've done it, your focus level is at that somewhat focused. Because you're not trying to see, first of all, do I know how to do it? If you're trying to do it first to see if you get the right answer, that would be in the really focused stage, because then when I write the answer down, now you can check, did I get this or not? And it's a way of studying already. Because if you got it, you get that reinforcement that says, hey, I know what I'm doing. That means on Friday, if this question comes up, I have a good chance of being able to get it right. Yes?
Are our tests going to be like really different things? Or is it going to be the same as this?
Our tests, when we have our tests on Friday, it's going to be the same as what we've been doing in the class. That's why I have this booklet. You can look at what we've done since the last quiz. Sometimes we'll have quizzes that are smaller, just on a section of the unit. When we get to the end of the booklet, we're going to have a test on the whole booklet, all of it.
What if I started halfway through the booklet?
That's why the videos are online, so you can watch and catch up on the stuff that you missed. Okay. Ooh, we have numbers in front of brackets in 2 different places. Can you see the negative 2 is in front of this set of brackets? And then we have a plus 5a in front of this set of brackets. So to distribute, this negative 2 would go to these ones. The 5a would go to those ones. So with the blue arrows, I'll write my answers in blue here. Negative 2 times 4 is negative 8a. Negative 2 times a positive 7. Negative 14. Switch to green for the green arrows. Yes?
If it's a negative, like, times anything, if it's in front of it, is it always a negative?
Yeah, so this negative's in front of the 2. That'll always be a negative when you distribute it.
What if it was like a negative 7?
If it was a negative times a negative, that would go back to what happens when we multiply a negative times a negative. It's a positive.
What if it was a positive times a negative?
Which we're going to get here because this is a positive 5a times a negative 2 at the end. So the nice thing about these examples is most of the situations start to come up over and over again. 5a times a squared will be 5a cubed. 5a times 4a, well 5 times 4 is 20. A times a is a squared. And here we have that positive times a negative. That'll be negative 10a. So step 1 in this question is we distributed, and we had to distribute more than once because there was lots of algebra present. Now that we've got our answer, we're going to say, is there anything that can be combined? Because we want to have our answer simplified in the end. So here, I'm going to underline this one, negative 8a in black. Do we have any like terms with negative 8a? We have a negative 10a here. What about negative 14? Are there any like terms with negative 14? What? No. So I'm chose. What about the 5a cubed? Anything go with the 5a cubed? No. What about the, well, obviously there's only one left and it doesn't match anything else. So the only like terms I have are the black ones. So when I write my final answer, I'm still going to have a 5a cubed. I'm still going to have a 20a squared. But the minus 8a and the minus 10a can be combined. How many would you have? Minus 18. Again, you can think of your number line. If you start at negative 8 and you subtract 10 more, that's going to go to the left. It's going to take you to negative 18a, and then I still have minus 14. This answer is right no matter what order you write it in. So if you wanted to write the minus 18a first, and then the 14, and then the 5a, and the 20a squared, that would be fine. Mathematicians have like extra rules where they say, if you can write them with the biggest degree first, and going down to the smallest degree, that's even better. Do you remember what the degree of a term was? The exponent. So the degree of this one is 3. The degree of this one is 2. The degree of this one is 1. The degree of this one would be 0 because it has no variables with no exponents. Remember, this one has a variable. The exponent isn't written, but there would be like a little 1 there. So that makes that exponent or that degree equal to 1. And so this question, we have simplified it, we've distributed, and we've gathered our like terms. Okay? So try this one first on your own. I will put up an answer in a bit. How did we do? This 2x distributes to those. This negative 3 distributes here. So we would get 2x cubed minus 10x squared plus 4x minus 6x plus 15. Okay, so make sure, okay, here, I would say when you go to mark the focus section, right, this one you haven't written anything down, this one you didn't have arrows, so you're right now not focused at all part, which tends to mean that you're going to get to redo this course harder next year in grade 10. Okay? So, Aiden, you're going to
Where'd you get that?
sit here for the rest of the month.
The fact that you tried to steal. I didn't steal it. It's still here.
Because the focus here didn't happen.
You tried stealing $600 worth of
Okay. Yeah.
How did you get 15?
The 15 came from this arrow here to here in green, -3 times -5. Now let's check. First one is 2x cubed. Do we have any like terms with 2x cubed? No. Next. -10x squared. Are there any like terms with a -10x squared? No. What about the 4x? Yes, the -6x. And finally, the 15 is all by itself. So the only ones that are alike are the 4x and the -6x. So when writing our final answer, 2x cubed minus 10x squared, what do we get when we do 4 minus 6? -2x plus 15. And this is our final answer. So example 5 says 2 minus 8 bracket q squared minus 3q plus 4. And this example is here because this example is designed to tempt you to make a mistake. It's going to give you something so tempting that you'd want to do that most of you will make the mistake. You're reading the question. What do you see? You see 2 minus 8. You're like, ooh, I can do that. And that is the mistake because there's still order of operations. Order of operations, bedmass. Okay? Bedmass has brackets, exponents, multiplying, dividing, right? So we should look in our bracket. Is there anything we can simplify, any like terms in our brackets? No. Okay? Distribution, when we have a number outside of brackets, that means multiplication. And so distribution is part of multiplication, and that needs to be done before you add and subtract. So you're going to be very tempted in this one to subtract 8 from 2. But before you can subtract that, you have to do the distribution first, because it's multiplication. Can you see yourself being very tempted to write minus 6 at the beginning? Okay. So now I would just have the 2, and then that minus 8 goes minus 8 times q squared minus 8q squared. Minus 8 times minus 3. Will that be positive or negative? Positive. 8 times 3 is 24. My variable is just q. And then minus 8 times a positive 4, negative 32. So the distribution happens first, and now the brackets are gone. So now we can start checking. Do I have any like terms with 2? Negative 32. Perfect. Do I have any like terms with 8, negative 8q squared? No. What about, well, obviously, there's one left. If you underline it, it shouldn't be like with anything else. So putting things together, what do we end up with? Okay. 2 minus 32, where's that going to be? Negative 30. Because you're at 2 and you go back 32 spaces. Negative 30. Minus 8q squared plus 24q. This would be a right answer. If you wanted to write it in proper mathematician form, they would start with the q squared because it has the highest degree of 2. Then, so in your answer book, like if you're looking in the back of a textbook, they would have this written. Here's another one that's tempting to make a mistake on. So I'm trying to give you all, 5 and 6 are the temptation ones. Yes. Quickly. check if she goes. So, why is it tempting? Because this negative outside in front is really like a -1. And that -1 has to get distributed prior to solving anything else. So here, we'll still have the 4. -1 times -4, -4a. And -1 times 5b would be -5b. Do we have any like terms? No. So as a result, our final answer is done. The homework assignment that's written at the bottom of your page, you can put a line through it because it's from a different textbook, so we can ignore it. Yes, some of them are.